So let us start. Good morning, everyone, and welcome to this computer system webinar organized by HiPEAC on Spring 21. Let me introduce myself. I'm Domenico Siracusa. I'm the head of the Robust and Secure Distributed Computing Research Unit at Fondazione Bruno Kessler. And at the same time, I am the European coordinator for the Center EU Korea project. And we are very happy to that HiPEAC gave us the chance to organize this webinar and interact with with you today. And I would like to present you the work we have been doing on the creation and orchestration of cloud-native AI applications in edge environments. This is the agenda that we will try to follow, and we'll try to stick a little bit to that, is the following. I will start with a introduction of the Center project in the next 20 minutes. The idea is not to make it too technical for those who are not really in the field, but at the same time to give some technical details that may be appreciated by those of you who are already working on these aspects. After my introduction, we will have the presentation of two use cases, discussing what are the challenges we have been targeting and showing you how it worked for us. And those two use cases will be the one on ambient intelligence presented by Senvu Kum from KT, who is the other coordinator of the center from the Korean side. And then on robotic logistics, presented by Guilherme Gari from Robotic company that is working on robotic logistics. Then this should be around 30 minutes. Then we will have a panel session. Today we have an amazing roster of panelists. I will introduce them later. And we have some questions that we'd like to share with them and know what is their feedback about those points. Finally, we will take some time, to give you the opportunity to ask questions and discuss among us. That's more or less the agenda. So I would like to start with the introduction to the project. And of course, the first point is about the challenge we are facing. So when it is the case of deploying an artificial intelligence application, there was let's say, the way that this has been done traditionally, even in the recent past, which was deploying it in the cloud, where all the data that was collected by the sheer amount of devices and sensors that were located at the edge of our infrastructure was conveyed. And this application was doing its job and processing this information. And even if it was really a simple application, imagine an application that resembles one of the use cases we'll present you later on, so that you are in an office environment or in your institution, like for instance in a university, and there is a camera that should detect a person, recognize that person, and decide whether this person can have access or not to a specific building or to a specific room, for later on, doing some analytics and process it. The point with this kind of processing of data is that it all the information has to be sent to the cloud, where it is later on processed, and this has some drawbacks that you can see there in terms of latency, bandwidth, ownership of the resources, and privacy. Now, in the recent years, there was a trend that was emerging that has been named as edge computing, whereas you can let's say, you can process data closer to where it is originated. And this gives you some advantages, that are benefits that are covering those problems we had in, let's say, in a cloud-based processing in terms of latency, because the closer you do this to where this is originated, the faster you are in reacting to something. And of course, if you start, for instance, from your video, taking out some frames in a, let's say, in a first computing, let's say, in a first processing step, and then from the frames you go into some metadata, and you do this, as close as possible to your source. The data that you will have to transfer among these processing steps will be constantly decreasing. And yeah, of course, you can preserve data privacy because you can keep your data without sending it to, even storing or sending it to some resources you do not own. And what is interesting is that it's not about doing things really on the edge, but it's really doing things in what is being called the continuum between the cloud and the edge, whereas you have both a high computational capacity to low computational capacity, locality versus being far away. So this has attracted a lot the media and the attention of the let's say the people that is working on those fields, to the point in which it has been said that the edge computing is a trend that will color the software industry for the 2020s. And yeah, we are sitting as a project on top of this trend. But what we wanted to analyze is, if you have an application that you want to develop, possibly an artificial intelligence application, how it is easy to to migrate and from this let's say scenario to this one, and what are the challenges that are you facing? This is what the center project tried to address. And the first point is that it is all a matter of perspective. So we try to see at least two viewpoints. And you see this on in those slides. The one on the left, who is the application developer? The application developer has its own perspective. Is interested in the fact that the model that he has developed has enough accuracy, and when this thing is deployed, it completes the job in short time, or at least in the time that it feels it is suitable for his application. And is interested in user experience. She is interested in user experience. But on the other hand, we have the infrastructure operator. So the person that has to manage all these resources and has to put inside those resources, to deploy these resources, the different applications. So let's say the perspective there is more focused on the number of applications deployed, which is related to the number of customers, or the number either internal, let's say, or external customers that this infrastructure can serve. It has to be robust. It has to be secure. So as you see, the interests are really different. There is a gap that has to be filled here, which the Center project is trying to do. The Center stands for Decentralized Technologies for Orchestrated Cloud-to-Edge Intelligence. And the idea is that we are trying to support those two kind of stakeholders in creating applications that are AI-based, which means that contain some AI models or whatever, and are cloud native. What we mean by that, cloud native is a paradigm that has emerged in the last over the years, since I guess 10 or so, and it is a way to build your application by creating a set of microservices that can interact each other and serve each other, and may be useful also for, and may be easily moved, easily arranged, and easily managed. And once we have this AI-based cloud-native application, what we like to do, what we like to give support in operating this application anywhere and anytime in a seamless, efficient, and secure way. I will get into this later on. So this is actually, let's say, our part of the contribution. Of course, we cannot totally solve those problems, but we have done research on those directions. What are the key innovations that we have proposed? I'll start with the one on the bottom right here. So the first thing that we thought is, okay, we have to have AI models which are decentralized, which can be hybrid, which can be, maybe divided. I will talk a little bit about this later on, but which can better fit the resource-constrained environment we're talking about. Let's remember that the more you go to the edge, the less the resources you will have. It's not going to be the data center you're going to have in the cloud. The second thing we thought about is, okay, we want to, I'll go on the top left, we want have a computing platform that is that copes with this distributed heterogeneous set of resources. We'll have different regions that in different edge regions that we have to manage together with the cloud. And we want to take the benefit of cloud native service management here as if we were in a data center. Then what if we want to gather resources from someone else and we want to gather, even software for someone else? And we thought, okay, we can realize a blockchain-based framework to catalyze the offer and demand of computing and AI resources and still smart contracts, which can then be monitored and rewarded. And finally, what we get the data, we're going to have a sheer amount of data, and the point is we want to have a smarter IoT fabric that helps us in, and coping with this multiple data sources at the edge of the infrastructure. So this is a little bit of the, the introduction, which I will close with who we are. I mean, I presented myself, but it's a consortium of 11 partners, which, it's belonging to large industry. We have two large industry from Europe, one from Europe and one from Korea, a public administration, the municipality of Trento, two universities, one again in Europe and one in Korea, 4 SMEs that are 2 from Europe and 2 come from Korea as well. So Daliworks and Glucis are in Korea, while Kenchu and Robotic are in Europe. And finally, we have the 2 coordinators, who are 2 research centers. I've already introduced Fondazione Bruno Kessler. The other one is the Korea Electronics Technology Institute, to which Sengvu belongs. Then that's basically a little bit of the introduction. I would like to go now more into some technical details. So in order to be able to process things anywhere at any time, we want to be able to capture this data, process it, visualize that, and maybe act. In order to do so, we think that it is needed to have do something that is really multidisciplinary, crossing the boundaries between cloud, fog, artificial intelligence, and Internet of Things. Therefore, we try to propose not a unique thing that covers it all, but to create some platforms and to provide some platforms and services and tools that can realize the objectives I was referring to before. In order to do so, I would try to describe a little bit of them, and I will start with the services and tools. The point of services and tools is that when I said before, the application developer isn't really interested only in the business logic of the application. It's not really doesn't really want to care if the AI application is ready for the fork. Really, it's not its purpose, not and how to deploy this, how to cope with the fact that some resources are not enough. We don't think this is something on which the application developer should break his head. On the other hand, so we are providing some services and tools to prepare and to deliver the AI. I will discuss this a little bit later. On the other hand, when you are a infrastructure manager, you want to, you may have, let's assume we have different providers. Each one of those colors is a different provider, and you have from big, large resources to very small resources. The first thing you want to do is, if you have an AI applications that has been developed and has been packaged in the right way, then you want to be able to deploy it from the cloud to the edge in this continuum in order to cater to the requirements of the AI. Is it latency? Is it privacy? Is it bandwidth? Is it other application-specific requirements? It is about how to orchestrate this in an efficient way. And what if this application needs some data which are collected by some nodes that are not in your domain, or you need some other resources from other domains? What we are proposing, as I said before, is to use the smart contracts to join resources across these different administrative boundaries in order to facilitate cross-border AI applications. Once you create this joint resources, then you can easily manage them as you were doing on your own domain and orchestrate them. We did a nice demo last year at the ICIN conference, and you can see how this worked also in practice. So In order to give you the final perspective about this, I want just to discuss what is our workflow, and I will give you some details. So as I say, the first thing we would like to do is to help with the preparation of the AI. The first thing is about model preparation and optimization. Our colleagues at the Seoul National University, in collaboration with Katie, have investigated some AI optimization tools, how they can be applied in our context in order to be able to fit with the constrained resource. So we are talking about pruning, we are talking about AI quantization and other techniques. One that was quite interesting at the very beginning was about, partitioning, because you could partition your model into different parts in order to do something at the edge and maybe something on a server that is close by. In this way, maybe you could be able to preserve the privacy of your data by immediately getting rid of this raw data and getting already something that has been processed. But anyways, we have been studying different models to do so. We have been providing a model repository there that per se it's not, it's just a repository of AI models. The point there is that we have given the possibility to share models among organizations and possibly among different countries. And on this, we have developed some tools for data management to ensure that who's using the model that you are providing is in trust and is using those models in countries in which the legislation about privacy and other concerns is compatible, and what it may be not compatible. This was an interesting study, in my opinion. But once you have your model, which is being optimized, you have to create an application. An application is not just the model itself, but maybe you can use a database, can use other tools to process data and whatever. So we created the center-based container, which is a form of Docker container, in which all the necessary handlers and hooks are ready for you to create the container starting from an AI model. This has been developed by Katie in particular. Once you have your application ready, which is a bunch of microservices, we have evolved our service orchestration platform. This is done by FBK, so by my institution. The idea is that we have worked on top of Kubernetes by extending Kubernetes by means of the custom resource definitions in order to be able to manage applications as first citizens of the Kubernetes world, not just single containers, but a set of containers which talk each other and have specific requirements that have to be fulfilled as a global application. And then we have changed, of course, the way that controllers are going to choose to schedule this application within different regions. So it's a matter of not a single data center, but multiple heterogeneous regions. So you can therefore compose an application. You will see how it works in our demos later on, and then you can deploy it according to the requirements. Of course, your application will have some output. Another thing that we thought it may be interesting is what about, so of course, when you have an IoT environment, you get this data, you usually have an IoT platform that does the brokering for you, so provides all the data that is coming from the sensors. But at the same time, we thought that this capability of the IoT platform could be exploited also not only to provide you data from sensors, but also to collect and broker and disseminate with those who are registered to the platform the outcome of the AI tools, AI models that you're running within the same application or among applications, so that your IoT platform becomes kind of a knowledge base. It's not only about sensors, but it's also about output of AI. So say, okay, I've recognized person XYZ. So that's an information someone can use to say, okay, to do other processes later on. So this is also another thing that we investigated, trying to help who's working on this field to deliver AI. What is the idea here? A little bit. I mean, we know that there was a process in which, in the field of development, people went from, a normal application, from planning, coding, building, and testing their applications, so from developing them, but also this role has moved towards to also the operation side, where you deploy those applications, you operate and you monitor. Similarly, there is kind of a possible trend that may be emerging, which is the one of the IOPS, where there will be specialists that will take care of creating the model, building the model from data, and then delivering it and operating it. In a way, we are not saying that we're doing this. We're saying that we are creating some tools that can help there as with our platforms and services. Some of the things have been presented to you: the HiPEAC, the cross-border data management for the model management, the service orchestration for the deployment, the IoT platforms and the digital twin where we are serving our application, the monitoring tool, our application aware metrics, and the optimization of your models. Those are a few things that we're doing may help in this process. We're not really driven by this process. We are saying, okay, some of the things we have been thinking really can match this, this loop, this AI ops tool in the future. Just to finish, as I say to you, we are working in this cloud to edge continuum to support digital transformation, and we are building our platforms and services and tools. They are, some of them are, described in this picture. You can see also this picture on our website. If you just Google the Center project, you will find it, and you can click on some of this if you are interested. We are still working on some of the links. But I've tried this yesterday for this one. You can click and there are some references. Some of these tools are already open source. Some will become in a few months from now. But what we're doing is to serve some real world use cases. And I'm really almost done here. We are serving some real world use cases related to smart cities, smart warehouse, smart construction site, and smart office. I will present two of them. The two other one will be presented by the colleagues. We are working in the smart city. We are working in the city of Trento, where actually a pedestrian crossing has been equipped with some cameras and some sensors in order to understand if pedestrians are at risk while trying to cross that street. The problem is, of course, pedestrians are always more and more distracted, and because they are, they are exposed to an incredible amount of information with their phones and distractions. So we want to understand if, as I say, the pedestrian is at risk by taking, by trying to analyze cars that are recognizing cars that are approaching, if they're approaching fast, if the pedestrian is trying to cross. But we're also gathering also other information. If the road is wet, because maybe the car will have, will need more time to stop. So a set of information. Of course, here latency is of paramount importance because you want to make sure that you react on time, you alarm the pedestrian on time. Another one is the smart and safe construction sites, where we are trying to understand if there are, for instance, workers are wearing helmets, if there is any danger for them. Besides also, besides being able to detect things, here it's also amount of resources you have to use and bandwidth. You can imagine that construction sites may be very different, and it's not just always a plain site. So you may have a lot of cameras, which means a lot of bandwidth that you may be paying if you are sending data to public cloud. So there is also another of those challenges I've been describing before. With respect to the other two use cases, one is on ambient intelligence and the other one is on robotic logistics, but I'm pretty sure Sengvu and then Guilherme will present them very well and show them to you. So I will say I will just stop my introduction here. I hope it was informative enough, and I'll give the word to Sengvu.
Okay, thank you, Domenico. So, yep, I will proceed the presentation of one of the center's use cases. My name is Sungum. I'm with Katie, and this presentation is about the use case implementation of the decenter about the ambient intelligence in smart office. So more specifically, this demonstration is an implementation of smart signage service, making use of the decenter platform. So basically, it's a signage service. So if someone comes near to the signage device, the video will be captured by an IP camera on the signage device. And by analyzing this the video stream from this IP camera, the signage device or the edge device will identify a membership or affiliation of a person who's in front of a camera, and then displays relevant information according to the identified information. For example, if I come in front of a camera, then my affiliation is detected, and then the meeting room number or meeting room is displayed. Like, please proceed to the meeting room number 7, or yeah, something like that. So basically, it's kind of a simple application. So we have kind of AI application somewhere, which receives the IP camera, the stream from IP camera, and then analyze it, and then deliver the information to the display device according to the analysis result. However, when to place this application on a specific resources, we need a few we needed some a few considerations on the resources and some aspects here. So if we place this AI application on the cloud, then the cost might be a little bit increased, since we need to pay for the VM usage or the network bandwidth. And also the QoS can be a problem, since we need to upload all the streams to the cloud and wait for the delivery of the analyzed result to be returned. And also, yeah.
Sorry, Sengbu, if I'm interrupting you. Our audience says they cannot see any slides. I can see them. Can someone else say if there is the same problem with other? Is the same for all of the people in the audience? No, slides are okay. Okay, sorry for interrupting you. It's just a problem with one person. That please go ahead. Apologies.
All right. Okay. Yep, that's okay. I hope you can see it now. Yeah. Okay, let me continue. Yeah, so the privacy can be under the concern if we are going to upload all these streams to the cloud, since my face is included in the video stream. So instead, maybe we can choose to place this AI application to the edge device, like I mean on-premise devices, like at some edge device or the PC. So in that case, we may the cost may be decreased, since we are not going to use any cloud resources. The QoS can be better, since we don't need many network hubs. Privacy can be the same. However, the management can be somewhat bothersome if we place all the AI application on the edge devices. If we place them on the cloud, if we place the AI application on the cloud, then maybe we can take many advantages of the cloud computing technologies for the resource management or the AI application deployment. However, if we place the AI application on the edge device, then the management, like deployment or the update of an AI application, can be somewhat bothersome. So, we applied this use case on this center. So in this center, we can use we can distribute an AI application onto various resources, including the edge and the cloud resources. So for example, we can distribute the AI application, some part of the AI application onto the local device, while the rest of the jobs to the cloud resources. So for example, the video comes to the local edge device. It will do some kind of first analysis and deliver the intermediate data to the cloud, and cloud make the decision and deliver the final information to the to display device, something like that. So in the center platform, we mainly we made use of two existing technologies. The first one is container to make our AI application portable so that we can deploy them on either edge or the cloud resources. And also we made use of the Kubernetes technology to build a cluster composed of cloud and edge devices. Cloud and edge devices. So applying the center platform on use case 4 has got some of a few benefits. The first one is workload offloading between edge and the cloud. So instead of having one monolithic application and place it onto a specific resources, we can distribute the workloads onto heterogeneous resources like edge and the cloud. So with the center, we can manage cloud and match mixed resources, and this deployment of uh, applications on both kinds of resources are enabled. And to run that AI application on edge or cloud, then we need the resources that are capable of AI computation. So the center has the facility to identify some facilities. So the center knows which resources are AI capable and how they are capable. So upon distribution, we can choose a proper resource to run that AI container. And also, the center has a facility to ease the management of the AI microservices. With that, a set of uniform interfaces can be provided to the AI microservices, so it will help the management of AI application, including the AI model updates. So to implement our use case on the Decenter, the first thing that Decenter platform, the first thing that we did was design a microservice, design the architecture on microservice architecture. So instead of having a monolithic application, we have applied the microservice architecture on our use case. So this is the architecture of our use case. The first AI microservice is the face detector. It will retrieve the IP, no, the video stream from IP camera and detect the face only. And the detected faces will be delivered to the next one, the feature extractor. So this feature extractor will extract the features from the face and then deliver it to the membership verifier. This membership verifier applies those features to the AI model to identify a person's affiliation or the membership. And based on that final result, the application will deliver the relevant information to the display device. So we have composed our use case using three kinds of AI microservices and four microservice instances. To run and test that architecture and the microservices, we have built a heterogeneous cluster here. So we have used, basically is a Kubernetes cluster, but we applied the decenter technology to identify heterogeneous nodes. So it consists of a virtual machine on the cloud and 3 GPU compatible nodes and 2 embedded JSON nodes. So all the accelerated nodes are kind of NVIDIA devices. 3 of them are PC, 2 of them are embedded GPUs. Okay, so yeah, that's the concept of use case 4, and here I will give you the demonstration. First, I will present how we can compose that on our use case with the Decenter app composer, and how we can select the a specific resources for run AI microservice, and the end-to-end smart signage service will be presented. Okay. So yeah, this is the app composer of the Decenter. With this, this is a tool that can be used to compose an AI application. For example, you can just simply you can design your your application by simply dragging some microservice boxes here, and then by connecting them, you can specify some details of those microservices there. Let me load the pre-made the configurations for the convenience. So this is the service configuration, service design of our use case for. This is exactly the same as you have seen on the presentation. So there is a camera, which is an endpoint. I think I need to zoom in a little bit. Yeah, and points, and then we have 4 AI microservices in 3 kinds. So the first one is face detector, next one feature extractor, and 2 member verifier services. So with this GUI tool, we can ask the Decenter platform to deploy our microservices. Before we deploy, just let me check the microservice status here. So this is before the deployment, only the UC4 monitoring is deployed on the cluster, and nothing is running there. So we have designed. We can now apply our design by simply clicking the deploy button here. Okay, let me check the service status again. Okay, so we can see that a lot of some more microservices are now being deployed on the cluster. So for example, the face detector, sorry for I zoomed in a little bit, and the graphic looks a little bit not so beautiful, but well, anyway. So you can see the face detector has been now deployed to the node, on an embedded node, the Decenter Xavier, and the node is now running. It uses the face detector model, and something like that. The feature extractor distributed to the node, or one node with 1080 Ti, something like that. So we can see now all the services are deployed. So let's go to the final the service here. So we can, with this monitoring tool, we can see how those microservices are interact with each other to see the data and the service progress. So this is the input for the face detection. So this shows the camera input for the face detector. This is the input for the feature extractor, and the final membership verification results. We can check some kind of a few metrics which is important for the QoS delivery. Okay, so with these things, we can identify whether he or she is belong to group A or group B or something like that. And, okay. Yep. Yeah, that's it. Yeah. Thank you. Thank you, listen. Yeah. Cool. Okay. Yeah, that's how we used our tool to design the microservice architecture, and then deploy to the actual Kubernetes cluster. In the center, we have one more interesting feature that is the hot swapping of an AI model. So with this technology, if you have updated your AI model, it means that you need to rebuild the container and then to redeploy the that container to the cluster again. But instead of building the new container and redeploying it to the cluster, we have a unique facility that is called an AI model repository, and we can use it for the hot swapping of an AI model in a running container. So in this demo, suppose that we have changed our model to another one, like of the use case face detector. So with the GUI, you just specify a new version number, and then ask them to swap that AI model. So it goes to reload here, and then it will substitute the AI model that is actually running on the container. Okay, let's go back to the presentation. Okay, yeah. So that's basically the another slide for the hot swapping of a model on a running container. So when we apply the Kubernetes method to update an AI model, I mean rebuilding the container and redeploy it, it takes around more than 30 seconds to update on existing container. However, with our tools, the delay for the substituting on AI model can be decreased around 15 seconds. So it's kind of interesting thing that we provide in our decenter platform. So yep, basically that's it. So we have demonstrated how we can use the app composer for the composition of a service, how we can deploy it on the existing cluster, and how we can use it for the AI model update on our running container. Okay, thank you.
Singvu, before you stop the share, can I ask you to go to the application composer and click on one of the microservices you're going to to deploy, because this is related to some of the questions we got. Well, we will cover them later on, but as you can see, when you define the microservice, you can define well, the name, the image, the number of replicas you want, what is the CPU required. If you put 0, there is no limit. And you, for instance, can identify, this is the point I wanted to touch upon, some specific GPUs. So it is either like we collect those GPUs are exposed to this tool. So you can select if you need a specific GPU or just a generic GPU, and other things you can do. Like, for instance, override of the regions where you want to put this, or you can ask an algorithm to process this. I just wanted to, since there are a few questions related to these things, I was taking the chance to show something, then we can reply later on. Thanks a lot, Singbo. Thanks. Okay. Great. I would like to go to Guillaume now. From Robotic to present the other use case we are showing today.
Hello. Hello, everyone. Domenico, you can confirm you can see the screen is right?
Yeah, both you are on the screen.
Okay. So, good morning, everyone, or good afternoon for our people in Korea. My name is Guillaume Gary. I am an engineering from Robotic. This is a partner from the center. we work on the use case of robotic logistics use case. I want to introduce briefly Robotnik. Robotnik is a small medium enterprise that designs and manufactures mobile robots and manipulators, and it has more than 18 years of experience, and it's based in Valencia, Spain. And we are more than 50 members that we among electronic engineers, on mechanical engineers, software developers, and manufacturer specialists. In the center, we are the owner of the robotic logistics use case, and let me introduce you some of the problems we face on a daily basis. So one of the problems we have in robotic logistics is an automated way to move things around a warehouse without the need of an operator. So we use mobile robots in order to do that. So the problem we face here is that our customers want something really custom made of any for each use case in our industrial applications. So the deployment time comes in it's very high because we have to tune sometimes even each robot for the customer, and it keeps us a lot of deployment time. Another problem we have is the computational intense algorithms that we cannot use on board of the robots. That's because of two reasons. One is that the computer inside is not powerful enough to compute this, and the other is, even though if the computer has resources for that, our battery will be drained in a brief time. So we cannot use these computer intense algorithms. And that is a problem with us because there is a lot of algorithms that we wanted to use and we are constrained with that. Another thing we are facing is like our robots in the traditional way behaves like an individual, a coordinated individuals, but individuals. They cannot share, they cannot help each other. They cannot ask for the manager or the edge or device to help with some tasks. So in this way, they are behaving like individuals, and sometimes this is not the most desirable thing, and we want to make another things that provide us more functions. Another thing we have problems is related with the first point, is the version fragmentation. So because of the highly customized needs of our customers, we when the projects goes beyond some time, we face the problem of version fragmentation. Is that some robots has one version and some other robots have another version. So this is a problem with us, and we wanted something to solve it, but it's really hard to do that. At last, some of our clients, we think we benefit from the usage of AI services, but we have some problems with that. The first and the main is we are robot experts, and we don't know much about AI. We know the basics, but we don't know how to train models. We don't know how to deploy. We don't know what we need. And this is a big problem for us. And the other thing we have problems is that usually the AI cannot be deployed on board on the robot because of the same thing. It's a computational intense algorithm and will be draining our batteries. So what brings to this warehouse robotic logistics the center? The first of all is the center provide us the use of containerization technologies, in this case, Docker and Kubernetes. And what leads this? This is a fast and homogeneous deployment. That means that we are going to do one container. We're going to separate some things that is specific for this robot, but we can deploy the whole fleet in a very fast and very homogeneous way. It's a very important thing for us. Also, because we are not an AI experts, we can use an AI customized packages, a model from external providers in a private and an easy way. Because cameras are sensitive data, and we cannot upload to the cloud because of privacy, because of the privacy of our customers. And also, we can use some of the AI services that we cannot do before. Another important point is that now the robot fleet behaves like a swarm. That means that some of the robots can be offloaded of the computational processes they have to an idle robot or device robots. That leads a battery saving and longer run times. It's very important for us because this kind of application, the robots should work in an ideal way 24/7. So at last, we can add an object recognition in order to improve our decision in the multi-robot management. So this is the center gives us very good benefits in our use case. So let me show you this setup. We are going to see. We are going to use robots that is our robot is called RB1 base. This is a transfer robot for a warehouse, and we're going to connect to the router to the cluster. The robot is also part of the Kubernetes cluster through a wireless network. Also, we have another region. This is the edge. This is composed, in this case, for 2 edge nodes that are NUCs. So in this edge region, we're going to deploy a fleet management system. The fleet management system is a software who has a front end and a back end that allows us to command the robot and give them missions. Is go to pick the goods from point A and bring them to point B, and etc. And this fleet management also manage multi-robots, so we can manage more of that. So the next thing I want to show you is the powerful of this center in order to reduce the computational saturation of the robot. This is a graph. When we on the left hand side, you can see that you can see the robot before offloading some of the processes. So you can see that we are around 2 CPUs on the normal usage, and when we offload some of the processes of the robot, we achieve more than 25% of CPU saving. That for this kind of application is really is really good for us, and it's really interesting. So this is the same graph, but as you can see in this, the load that was on the robot on the left hand side goes to an edge device on the right hand side when we do. So the features keeps the same. So I'm going to show you a video about the smart obstacle detection and smart decision, and this is what you're going to see. It's like with the fleet management system, we're going to ask the robot to go to a place, and this place will be free of any obstacles, or will be with some different obstacles. These obstacles will stop the robot due to safety reasons, and and the robot will take a picture and will send it to the AI service provided by another partner, and this AI service will return us if there is a human, a robot, or another thing that an unknown obstacle. So our fleet management system could make a smart decision. So in order to do that, also the robot will show different colors in order when he is detecting different things. So as I already said on the video, we're going to show you because we wanted to do a live presentation, but with the time constraints we have, because the robot doesn't move as fast as in the movie shows. We have to, for safety reason, we have to move kind of slow. This demo will be shown with a video. And we're going to ask the robot to go to point A to point B, and will be placed different obstacles. And when the different obstacles is detected, the robot behaves in a different way. Before the center, we cannot do that because we cannot use the AI on board. So this is a great feature for us. So let me start with the video. So this is the robotic one. As you can see, as Sengu said, we use the Fogatlet app computer in order to manage the robot and the fleet management system. So as you can see, we are running using Kubernetes, and now in the video you are going to see the deployment of the robot. And as you can see, it's deployed on the robot all necessary microservices. And now we are going to present the scenario. Well, this is the figure we saw before, but the robot is going to ask to go through the door A to pick some goods, and if there is some obstacles, they will be asked to reroute through the door B. So this is a great advance, because before that, the robot will stop permanently, assuming there is a person. So this is the first one that is free to move. So it's going to bring some goods to an operator and return. On the left, on the bottom, you can see that a digital twin of the robot, and the what is the robot seeing. On the upper side, you can see different cameras in order to visualize what the robot is doing. So now we're going to put a box in front of on the path, and the robot is going to switch the lights to yellow because yellow is an unknown obstacle. As you can see, is detected as others. So what it's going to do is going to replan the route and going to the door B. So before the center, this won't happen. The robot will be blocked here permanently until the box is removed. So now our robot fleet behaves in a smarter way. Even though this route will be permanently blocked and alert the user. So as you can see, even with an obstacle, the robot can deliver the goods. And also it's going to return to the starting point. This part of the video is a little bit speed up because it's not funny to see a slow robot moving, and I think you got the point. So the next one will be a person in the way, and in this case the robot will show red lights and it's going to alert the human in order to move away. This is going to make noises that is not you're not going to hear, but as you can see, it stops and continue to do the work, but is alerting the human in order to move away. And at last, we're going to place another robot in front of there. That is a very common scene here. So in this case, the robot is going to show blue lights because it detects a robot, and it's going also to the route. But in this case, the route won't be blocked permanently. When the mission finished, the robot this path will be free again and will allow other robots to use it. As you can see, the other robot is moving around, and as you can see, also the robot could bring the goods to the operator and complete the mission. As you can see, the robot is going back. So as you can see, this is a smart decision and obstacle detection. Okay, so sorry for, I think I closed my, but my presentation is finished, and thank you for listening.
Thanks, Guillaume. I think that besides the exact specific case in which I was about robot moving, the demo shows that it is possible. I mean, we have been, let's say, by orchestrating resources on those robots, it is possible to put some AI intelligence and also to do some tasks that Robotnik was not able to do before. There are some advanced use cases that we don't show here and are more related to how can you use those robots as a swarm, and their orchestration becomes more and more relevant. But yes, of course, we had a limited time today, so we stick to what we showed. Indeed, we are a little bit late, but I think we can still make it. So the next thing will be for me to share my screen again and to go ahead with the next, let's say, part of the session. You should see me now. So we basically have the panel now. I've seen there are quite a lot of questions in the chat. We will try to answer them. But now we would like to go for the panel. Today we have 4 amazing speakers. The first one is Mohsen Amiri Bashiri from Konica Minolta. He holds a position and the research technology manager of Konica Minolta Global R&D. He oversees and collaborates in a portfolio of projects, publicly and privately funded, with a strong focus on cloud edge orchestration, cloud robotics, future networking, including SDN and 5G, pipeline, and intelligent workplace. Is working on different stages of R&D life cycles, including concept design, feasibility, prototyping, and process enhancement. He holds a PhD in machine learning and MSc in computing with international business and a BSc in software engineering. He has years of experience in design, implementation, expansion, optimization, and maintenance of systems on cloud edge infrastructure based on Microsoft, Google, and Cisco technologies. Welcome, Mohsen. And welcome to this panel. The second panelist is Dr. Youngwoo Jung. I hope I pronounce it well. Is a principal researcher at Computing Research Division in ETRI since 2000. His research focuses on cloud computing and virtualization from different perspectives. During the last years, I've been working on cloud computing solutions and technologies with a particular interest on distributed cloud architecture, multi-cloud, and cloud-based brokerage. Moreover, he has served as the national coordinator or participant in several international projects such as Basmati, IH 2020, BISCA, ERICA, and many from ERICA as well. And as the project coordinator of several national projects related to cloud computing and virtualization. So hello and welcome to this to Youngwoo. Then we will have Cristóvão Cordeiro from 6SQ. He is as a Docker certified R&D technical project manager at 6Q. He has an MSc in electrical and computer engineering from the University of Coimbra in Portugal. And he has launched his career by joining CERN as computing engineer, specializing in integration of cloud computing resources into the largest distributed computing grid in the world, the WLCG. He is now leading the development of 6SQ edge computing software appliance, the Nuvla Box, whilst contributing to various European projects such as Elastic, MF2C, and OAK. So welcome to, yeah, I don't see your cameras. Please put them on, Cristóvão, Mohsen, Danilo, and Youngwoo. So welcome also to Cristóvão. And then we have finally Professor Danilo Ardagna from Politecnico di Milano. He has a master and a PhD in computer science from the same university. He was visiting a research at EABM TJ Watson Research Center and at the Basco Center for Applied Mathematics. His research interests are performance modeling, cloud fog systems, resource management. He has developed solutions for supporting web services compositions, optimizing virtualized systems, and advanced schedulers for big data and artificial intelligence applications. He didn't write so, but he's, I know it, so I can say that he is the coordinator of another European project called Sprint AI, which you may be interested in looking at. Okay, so welcome to all of you. I'm glad to have you here. Well, I will start with the panel and with the questions to you. Yeah, I have put them also in the slides so that you can, you can read them. The first one is about the hype around edge computing. So we know there is a lot of hype on edge computing. The point is that there are not all, not all of the countries, not all of the industry in the different countries, and the relevant stakeholders are really embracing this concept. So what is the real state of the play according to your understanding in your country for the adoption of edge computing? How much of these technologies we have been talking about have been adopted so far according to your understanding? I would like to start maybe in the same order we have here. So first Mohsen, then Youngwoo, then Cristóvão, and finally Danilo. So Mohsen, I know you are not from UK, you work in UK, so you can both choose either your native country or the country you work with.
Hello. Yeah, I would like to, first of all, thank you and appreciate the time that you have given to me for today's discussion, and also tell you how much your project inspires me and a lot of other people. That is an excellent way of looking at edge AI. And as a machine learning enthusiast and as a cloud guy, I can tell you that you are right in the center of the shift, the paradigm shift that is happening in the world. Being in Konica Minolta means that I'm not going to talk too much today about UK, because Konica Minolta is a conglomerate. We are operating in 49 different countries, and I happen to be based in the UK. So I try to give you a little bit of more of a global side of the business. I want to start with some numbers, if it's possible. I often quote these numbers for very, and I try to be very quick. Look, edge computing is no longer a hype. It is a reality. If you look at IDC's 2021 report, it is very clear that people are relooking what edge computing means. 97% of the businesses using globally, enterprise businesses are using public and private cloud. And by private cloud, they're talking about stuff that you have actually shown. 86% of companies, and I can tell you, we can see that in our own business, are repatriating some of their workloads to the edge. This is very important. We understand that maybe a year or two ago, all the hype was around cloud-first strategies. People were talking about the fact that they want to move everything to the cloud. But there has been a shift. The reason is quite simply economy of keeping stuff in the cloud. It's not as cheap as it looks like. It is also not, there are some regulatory laws that people don't like. Let's say they cannot appreciate sending all their stuff to the cloud core when they don't have full visibility. Although a lot of CSPs are doing stuff in that respect, but still there are people who prefer to have their stuff on their own edge. And there's, and on the same time, you have a huge CapEx that companies spent in the last few years building data centers. They want to utilize them. And your use case showed another facade of the same story as well. You have talked about low latency, and this is basically laws of physics. You cannot have your workload really centered to the cloud. You need to have some of your workload at the edge. And in addition to all these things, we are seeing an uptake into orchestration as a concept that people are more and more utilizing in their organizations. And why that is happening is quite impressive as well. There are a lot of free open source orchestration tools, and people are realizing that things like Kubernetes, Docker, or whatever you're using are very capable of being providing distributed cloud. It means like one-to-one services that you could get in a public cloud at the edge. Adoption speed is increasing. COVID has actually increased that speed. It is very clear. Amount of people who are inquiring about things like edge computing are increasing. And in addition to that, you have 5G and what we like to call future networking as well. In the UK, future networking is getting cheaper and cheaper, more available. People are thinking about low latency. No matter how fast your 5G connection is, if your workload is located in Singapore or Tokyo, the latency will be there. So to actually utilize the latency, you need to be capable of orchestrating stuff closer to the edge. I can talk about machine learning and the patterns that you have talked about. I've seen that you mentioned graph patterns. You actually showed graph patterns for machine learning, which is quite impressive. It's one of the major use cases. Another thing is control pattern AI applications, which are stuff like industrial robotics that we happen to work with a lot. And then you have swarm pattern, in which you mentioned that you are actually looking at, and I think your solution is capable of maintaining swarm AI patterns as well. So I don't want to talk too much, and I have the habit of losing time, but just wanted to say
that was great. That was great. Thanks a lot, Mohsen. You gave gave a global perspective. You gave us some numbers. That was really up to the point I really wanted to know. So thanks a lot. That was really effective, and I'm sure our audience has appreciated this global vision from Konica, which we know it's a multinational, is working all globally. Then we have a different perspective from, let's say, academic or say research world. I will ask the same question to Youngwoo from, I don't see from Atri. I don't see you on the camera. Here you are. Okay. Good afternoon. And yeah, the question is actually the same. So.
Yeah. Okay. Good afternoon. So first of all, I thank you for inviting me to this good workshop. So actually, when I heard the overview of this center and the impressive use cases, it is very impressive to me. So actually, when I heard the first questions, I looked into the related investigation report in Korea. So actually, when I see the report, the main use cases for edge computing applications in Korea can be divided into the smart factory, smart farm, and then the autonomous vehicles. So actually, in the smart factory field, the many system integration companies such as LG, CNS, CJ, Hyosung, and POSCO, and are currently making business in cooperation with the other solution companies. So in the case of smart farms, normally the R&D project and services progressed led by the local government. So that is the current situation. So, and then the most important thing is the autonomous driving industry. So actually, you know, the reading the car maker in Korea, such as the Hyundai Motors and Kia, and then as well as large companies such as LG Electronics and small SME companies such as Chemtronics and so on are carrying out the autonomous driving related businesses. So actually, in addition, the KETI, as the Korean partner of this center project, is also developing the next generation vehicle communication chipsets and solution for the autonomous driving services. So they are conducting now the CITS demonstration project in Seoul, Jeju, and Ulsan. So actually, I mentioned the edge computing technology in Korea is now being adopted and expanded in the various fields. So I think the edge computing will the business market will grow more and more in Korea, I think. Thank you.
Thanks a lot. So our two first panelists, Mose and Youngwoo, are telling us, okay, look, it's not really an hype. It's something that is happening, that is really happening. So then the question will be for Cristobal from 6SQ. Yeah, let us know your opinion about this. Good morning.
Yeah, so let me just, same as the others, relay their message to thank you for the invite to be here. So far, I really enjoyed your presentation. I actually have even a few questions that I might catch up with you after this. So congrats on your work. So regarding this question, well, I'm Portuguese and I'm living in Switzerland. So I've had a bit of experience working with companies and activities towards edge computing in both places. And yes, I agree. I agree with the comments that were done before me that I would not call this a hype anymore. So it's pretty much established that edge computing is a very valid approach towards computing and decentralization. However, I do see that there is obviously not so much awareness as you have for cloud. Cloud has been established for years. Edge is more or less recent. So I sometimes see that there's a bit of resistance, both from companies and general public when it comes to edge computing, either because of lack of awareness, because usually edge computing, when you talk about smart cities or some smart like AI, not always people see what's happening under the hood. They just see the impact of it, and therefore it can kind of passes unrecognized. And also there's a bit of resistance when it comes to the fact that there's a well-defined higher security attack surface, because the devices are closer and physically more available to general public and out there outside control environments. So I do see some resistance there, and that's why sometimes we have worked with at 6 Squared with actually some big players that are also trying to go into the edge computing space, but because there isn't such a well-defined path for adoption as there is for cloud, for edge computing, some of these big companies are actually trying to find their way into it. They have to deal with data distribution, migration. They have to deal with the orchestration, as we were saying before. And even though there are open source tools for orchestration and container management and all that, not everyone has the expertise to just take that in and make it work in such a way that the end users do not need to be experts on those, because that's one of the main resistance points as well, is that the end user usually is not expert enough on all of these tools. The cloud works the same way. You have abstraction tools for managing your workloads and your VMs and so on. So for the edge, we need the same thing, but it's still a bit hard for companies and people to adopt it because of the general understanding of all of the tools involved in edge computing. Nevertheless, at least in Switzerland, from my perspective and from my past experience at 6 Squared, we have actually worked in multiple fields. So smart cities, same as your project, is probably the biggest one we have worked with. So in Switzerland, we have several projects ongoing and already deployed as well in smart lighting and traffic detection and all that, both with cameras and also with sound, which is actually cool. You guys are doing this with cameras. That we have worked with a company that is doing it with sound. So you have microphones on the street, and they use AI to detect cars passing, and they count cars and the amount of traffic on a certain street. And also we have other projects and other past activities on the scientific field, Earth observation. We have humanitarian efforts. So for example, companies that want to put intelligence applications for hospital care, for healthcare in remote places, underdeveloped countries, they start using edge computing as well. And one other domain, which is not very talked about, but I really enjoy, and I think it will be coming a bit stronger soon, is retail. So people are also trying to use edge computing to bring the customer care experience from online shops to physical stores, and using edge devices for that. So I've seen this. This is what I've seen at least in Switzerland, and it's going bigger as well.
Oh, okay. Sorry, I could ask. I think those who are not speaking to mute themselves. Cool. Sorry. That's great, Cristobal. Thanks. I have some of part of my feeling is aligned to yours, because I mean, the barrier of adoption is not so easy to overcome. For those companies that are really, let's say, in the forefront of their research, that may make sense. But for some companies, this is not really the case. And maybe we can hear also something on, I don't know, on this line or a different line from Danilo. From Politecnico di Milano. Sorry, I have to mute.
Okay.
Okay, yeah. Please go ahead, Danilo.
Thank you. Yeah. So thanks also for inviting me, and I mean, congratulations for the work you did in the center, because I think it's a very interesting project. So for what concern, I will go straight to the point. I mean, for the sake of time, I think, because we are running, I mean, a bit more than expected. So I would say that I agree with the colleague from Korea, because I saw in Italy also some the smart factories in smart industry, which actually are adopting several edge solutions. The main, I think, is in the robotic side for the large industry, the large companies. But actually, the edge is also supporting some advanced applications for monitoring the status of the different apparatus of different manufacturers. So, for example, I mean, they are using also AI for detecting failures, hardware failures, just from the noise, for example, just to mention some more advanced solutions. I agree also with the previous speaker. I saw a lot of interest. We are still probably on the smart cities area, let me say. We are still at some prototyping solution. And actually, I would mention the work done, for example, in the south of Italy from my University of Messina. There is a very active group working on edge computing, osmotic computing, actually. And there in Messina, what they did is really amazing. There are a lot of sensors in the city, which this, I mean, the data got from the sensor is also mixed with a weather forecast. So they are gathering weather data, noise and pollution data. They are monitoring parkings, and they are monitoring energy consumption also. So, and on top of these, actually, they also, I mean, provide the data for building more advanced AI or, I mean, in general, machine learning applications for predicting the usage of energy, for example, from the different customers. And finally, I would mention also its use in healthcare for sure, because of the data gathered from the different patients that then are centralized and analyzed, for example, at some hospital level. And then, I mean, according here also to mention some advanced AI applications, hospital, what they're starting doing is also federated learning, for example. They cannot share the data of their patients among different hospitals, let me say, to simplify the things. But I mean, the federated learning is a nice way to build more accurate AI-based model for, I mean, for prediction of the health condition of the patients themselves. And finally, if we look at the insurance world or the finance world, actually, for example, my car insurance, I have a box in my car, and then they monitor the way I drive, and actually I have a discount because, I mean, they can monitor how much I drive. And so given the kilometer I drive, I have a different profile plan. But actually on the finance world, for example, I know that some banks have some investment institutions have some camera in the seaport, for example, just monitoring the boat coming in and out, because this is also something that they can use to monitor the health of the economy, of the city, of the country. So they make decisions according to, I mean, among all the different financial indicators they consider, they are also considering these traffic, let me say, in the main seaport of the countries. So that's an overview of the edge computing applications that I'm familiar with. I've been in touch.
Thanks, Danilo. So as our panelist speaker said, there is a lot of deployment. You got, I guess that you got plenty of examples of interesting use cases in the field of edge computing and artificial intelligence. You may also look in the future. So I would like to thank all the speakers, all the panelists for answering this first question, which brings me to the second one. So now we get into how can we seamlessly deploy AI applications in cloud edge infrastructure. So we were trying in the center to tackle some of these points. Is there something that you believe we have been missing, or for instance, something that you believe it will be important to improve the interaction between developers and infrastructure owners? How can this be facilitated? So, well, it is usually, I had experience that were different from this when I was doing panels where the speakers were not so talkative, but today I'm really happy to have a panel that is really helping us in understanding well the things. But in the interest of time, since it's already 32, I will kindly ask you to keep a little bit the time in consideration when you're answering. So, and I will also love to see if there is anyone that wants to answer to this specific question. So instead of me doing round, if anyone wants to speak, just let me know and start talking.
Sorry, can I just interject very quickly? This is
let's start with Mosi. Yeah.
You knew, you invited me, I need to talk, so and that's your fault. Look, I agree with all the comments that have been made. Let's I just think that, and this might be my experience of working with a wide variety of customers, right? We are talking about 2 to 3 million companies that we are dealing with. Actually, very interestingly, edge computing is getting much more interesting with what we internally call a mundane application. So you can see people are talking about like any event-driven system and any data-driven system. Just for the sake of cost, they're looking now at the edge offering. And a good indication of this is the presence of the CSP, hyperscale cloud providers in this area. You cannot avoid looking at Azure Stack, Anthos, or I can talk for hours about that. But let me just go very quickly talk about AI, and we can talk about that even more because it seems to be something that Konica Minolta is doing a lot because they're a huge camera manufacturers, and in many cases people are asking about the application to detect stuff on there. Look, AI pipeline is, and I totally believe this. I think there is no siloed machine learning. Machine learning is hybrid by definition, especially if you look at all the different steps that we have. So we are now talking about MLOps, right? You need to set a goal. You need to gather a lot of data. Where are you going to gather the data? You need to run different models to find the better model. You need to constantly check to find what we call a drift in the model, if the model is actually doing what it's supposed to do or not. So there is a room for solutions like vCenter. You don't necessarily need to touch ML and DevOps tools like TensorFlow, Jupyter Notebooks, and those kind of things. But where it comes to hybrid cloud platforms, things concerning containers, Kubernetes, and DevOps for machine learning operations, and maybe in future AI ops, but AI ops is very data driven, so you need to gather a lot of data. I think that there is a huge need for that. The process is really, really time consuming, because imagine if you sell somebody a camera, it wants to detect a defect in their factory line. You have a training process, and then you have inference process. While you might be able to ask people to kindly send their data for training to the cloud core, it is really hard to ask them to do inference on the cloud, both for latency and cost. And cost is a huge driver here. If you end up paying much more than the cost of having a person looking at the line instead of using a camera, you have a very good sales case. And two more things, LTV and CPA. I think long-time value of the center is really, really justifiable. Having said that, because these sorts of infrastructure solutions are designed in a way that people need to stick with it, probably the CPA is cost per acquisition of client is probably a bit too high. And you need a backing of a very good sales organization to be able to convince people to go on infrastructure that you're proposing. I will stop here, not go to the details, but my point here is AI MLOps, the better word to put it to just distinguish it from AI ops, cannot not be hybrid anymore. At least the inference needs to happen at the edge. Yeah, sorry.
Thanks a lot. That was great. I think that was great. Someone else that wants to argue, even all of you, but I don't want to.
I'll just give a quick, straightforward, blunt answer to your two questions on the slide. So, at least from my perspective, one of the gaps I've feel is quite relevant is that for AI-based applications, because they are quite resource demanding, there's a gap that still needs to be explored in my perspective, which is the exploitation of in your use case. I think you are working with two Jetson nodes. The question is, are those clustered, which I assume they are because they are in a Kubernetes cluster, but how do you manage clusters? You are going to have fleets of edge devices geographically distributed everywhere. So you need some powerful and sane management system for those devices, because you want to be able to not only distribute your AI applications throughout multiple devices in one go, you want also to be able that those devices can share data between each other so that the AI applications do not need to send data to the cloud and then fetch it back to the edge. So I think there's work ongoing there, but for me, that's a gap that still needs a bit of refurbishing.
Cool. So that was more into the specific orchestration technologies and the not only orchestration, but also virtualization technologies and so on and so forth. That's a different perspective, but it is really interesting as well. Thanks, Cristobal. Anyone else, or shall we proceed with the next one? Okay, let's go. Yeah, that helps me in trying to finish those questions. Thanks. I'll go to the third question. I have 4 questions. Maybe we can skip one, but this one was quite interesting to me. And it's a little bit, we go back to the market. So we discussed about technology. We discussed about what other use cases you see. Then we discussed about AI technologies. How can we fill this gap between cloud and edge? We discussed with Mosen about the fact that it has to be hybrid, and with Cristobal about the fact that you need to cope with the diversity, that it is still something that we have to deal with, a technology diversity. But now I'm asking you, I mean, there is the cloud market. If you look at the cloud market, it's really pretty much dominated by big players. We always cite them: Amazon, Microsoft, and Google, and so on and so forth. The point is, will edge be the right lever to democratize this market? And I was considering this when I was thinking, okay, look, also, operators, our network operators have a lot of edge instantiation, but I've recently seen in Italy, for instance, that our main operator is making agreements with Google, for instance, to give them their edge. So I thought maybe we're not really doing this. We are getting back to big players. So the question for you is, will edge be the right lever to democratize this market? And what do you think about even dynamic resource federation, where maybe small players can put together in order to, build a strong offer that may be competing in this scenario? And again, I would like to ask you, just who wants to speak, just start, and then we don't follow the order, but just we go for those who we want to answer. Yeah, yeah, okay.
Yeah, sorry.
Fine.
The democratization is not really a problem, to be honest. There are services like Reach. If you look at Reach.io, for instance, I'm citing some brands here, not that these are our brands. More and more people are realizing that the assets, the CapEx assets that they have, can be utilized as some sort of value generator. So there is this movement now that you see companies, and I can provide the names of some of them to you. One of them is Rich, which basically what it does is enables your data center to be part of some sort of consortium of companies and run workloads in your thing. So basically they're orchestration as a service. So their model is, we will not guarantee precise reliability SLAs, but through distribution, we manage to put your workload somewhere around. This is very important for content delivery systems, for example, or gaming. We recently in Konica Minolta supported BAFTA, the show, the Oscar of the Britain, and we designed their cloud gaming. We use cloud gaming for have like immersive technology for people to clap. It was 99% edge computing and a little bit of AWS. So I think the answer to this question is big players are not going to sit still. They are actually working on edge computing. You now can say that even in the carrier grade stuff, you can see a huge presence from Microsoft, even Alibaba, Tencent. Let's not make it really Western oriented. So they're going towards providing edge, and they have more resources. Having said that, the competition here is a lot more interesting than the competition in the cloud. Case in point, Equinox or other people. There is acquisition going on, so big players are buying those smaller players. That's true. But to extent, I think democratization will happen, and edge is a different game because actual location matters. If you have 25 data centers, many enterprise people have, let's say in Saudi Arabia, you're Aramco, you have data center, and this data center is not connected to your necessarily your critical infrastructure. The point is yes. And this thing is happening. They're raising a lot of new unicorns are being created just for that. Just you look at the market shift. So a lot of companies are coming in, and this is more interesting in India sphere as well, because they have a lot of local cloud providers, which are a lot cheaper. And now you can see that they're offering their stuff as a part of consortium, and they have orchestration as a service on top. But this is more for mundane workload, not necessarily for robotics and stuff.
That's great. So it seems that democratization is going to happen. So there will be, edge will give actually this possibility to the stakeholders that are launching in this field. Anyone else of our panel would like to argue about this?
Maybe I can add something.
Yeah, then we give the word to Yongwoo after Danilo, because also I was pretty sure he had something to say, but you can go, Danilo, and then we go to Yongwoo.
Yes, I'll try to be short. I definitely think that something more interesting might happen because of the edge. I mean, it's difficult to predict what will happen with the unicorns, with the big players, and so on. But for sure, for example, I can bring the point of view of Europe, and actually also the European Union is trying to foster actually the cloud federations, because there are the big players, our European cloud players. It's difficult for them to compete on that, and the European Union actually is pushing a new alliance for industrial data and cloud, which actually will be launched at the beginning of this year. So there is I believe that I hope actually in a way that our cloud players can be strengthened, can get a better position in the market. And I definitely believe that the edge is a new opportunity for them. And I agree with you that for sure also that's a great opportunity actually for our telcos too. Because I mean, when you link these with the 5G also, right, becomes the mobile edge cloud. I mean, they should be really the one that should invest in this direction and can gain a lot by this new technology. So yeah, I will stop here.
That's great. Thanks, Danilo. That is also an interesting perspective. We'll leave the word to Yongwoo.
Okay, thank you. So actually, the current the cloud market has been dominated by the big cloud service vendor such as Amazon, Microsoft, and Google. So I think it is not easy to solve this situation by the edge solution, because the major vendor is also providing the edge solutions, such as the AWS IoT Greengrass, Azure IoT Edge, and so on. So I think we need to consider another approach for solving this kind of vendor locking problem. So I would like to introduce the concept of multi-cloud to overcome this problem, which is the new emerging technology in the field of cloud computing. So actually, the multi-cloud is the technology that connects and utilize the public cloud services provided by multiple cloud service providers. So users can select, deploy, and utilize the optimal cloud services without being dependent on the specific vendor. So I think this can accelerate the emergence of various edge solutions that are not dependent on the specific cloud service providers. So that is my opinion. So actually, currently I'm working on the open source project for the multi-cloud. So the name is the Cloud Barista. So actually, you can search the Cloud Barista on the web. You can access the GitHub site, I think. So I think this is a helper to you. Thank you.
Thanks. Sorry, there was some connection issue, but I think we all got most of. No, but I mean, it was just the last word, I guess. The rest of it, I could hear it very well. Thanks, Yambu, for this perspective of multi-cloud. So that is interesting and technology, and of course that may avoid vendor lock-in, and that's also an important aspect. I don't know if Christopher wants to add something like in a minute, if possible, or.
I'm just piggybacking on Young-Woo because that's basically our motto. It's no vendor lock-in, and if you also go and check on the work that we do here at 6 Squared, it's basically edge to cloud ecosystems with multi-cloud environments. So
that means you are really aligned with Young.
Yeah. So the answer.
That's perfect.
Yeah.
That's perfect. So yeah, I would like to. I have no basically time for a proper answer to the last question, but I would like to do one thing. Ask each one of you to say one, at most two keywords that you believe are interesting. So, I mean, we wanted to ask you, considering Horizon Europe and worldwide research and innovation on cloud, IoT, and AI technologies, what are the challenges that deserve to be prioritized? So I don't have the time to ask you a full answer, but tell me two keywords about the things you believe have to be investigated in the next future. Of course, they can also overlap, but that doesn't matter. So I would just do a quick round among all of you, starting from Mosen, maybe saying, okay, two keywords that we should keep in mind for the future research and innovation on those fields.
I would say multi-cloud is one of them, and orchestration.
Good, thanks, Mosen. We go in the same order, in the order. So Young-Woo then.
Okay, so actually, I'm mainly working on the cloud side. So actually, I would like to introduce the new concept of this cloud, distributed cloud. So actually, this is the distribution of public cloud services to the different physical locations, while operation, governance, evolution of services. So, I think it is a good topic, but the distributed cloud is also a model that can be provided by a specific cloud service vendors. So that means that there is still the vendor lock-in problem. So I think this problem can be supplemented by the multi-cloud technology, which I introduced before. Thank you.
Thanks. So multi-cloud, distributed cloud. Christopher?
Yeah, for me, I would say one, distributed data management at the edge. And two, I would say general technology awareness.
Okay. I expected security as well, since you mentioned before. To me, this is like an open field for security. Yeah. Edge computing is really crazy, but maybe, yeah, that's great. Thanks. And finally, Danilo.
Yeah, from my point of view, the challenges come from the integration from the IoT world, because if you look at the new AI sensor, the different vendor have some framework, specialized framework for their own devices. And I think one big challenge is coming from this side. And then I agree with Cristovao for the data management, because, you know, AI still today is 80%, data preparation, 20% is the model. And actually, if we can improve on the data size, data management size, we can get more accurate models. Just with the same technology, with the same approaches. So I would invest really on this.
That's great. That's great. Thanks a lot. And I would like to really thank all the panel speakers for answering the questions, for being, you know, elastic enough to cope with my, you know, going back and forth, you know, and asking to be faster or slower. Now we have those a few minutes remaining for the questions from the audience. I'm opening the question and answer, let's say, ribbon, and I would like to start with the first question. I see some of them already been answered. We may have the time to look into them as well. I would like to start with the ones that have not been answered, which were about the how are you handling guarantees for low latency and IoT applications. And I also saw a question about the front end, if the deployment tool is just a front end for kubectl. So I would like to answer this because it's something that we are dealing with. Basically, what we do in this center, we have extended Kubernetes, as I said, to with this custom resource definition to define an entity which is not anymore a single container, but it's an application. An application is a set of containers talking to each other with specific requirements on the single microservice in terms of, for instance, bandwidth, latency, container is CPU, RAM, and disk, and on the links between, let's say, on the connection between the different containers in terms of bandwidth and latency. Then once those are defined in the composer you have seen that Sang-Woo and Guillaume shown, there are algorithms that try to understand what is the best placement for these microservices into the actual infrastructure that satisfy those requirements and at the same time do not consume too much resources. There is the possibility in the tools that we have developed to both choose manual decisions or to rely on those algorithms. And there are different algorithms that depend on different objective functions. So the way we are doing this is once you have prepared your application based on the tools that we discussed, what there is a smart orchestration tool that decides where this have to be placed in order to cope with this low latency. Of course, this demands that you are capable of monitoring at the same time how the application is behaving. So you can monitor let's say, both the infrastructure on the single nodes and the connectivity among those nodes. And to answer also to the question, are we just developing an interface of kubectl? Well, we have first let's say, extend the Kubernetes not only for this concept of applications, but also with the concept of geographically distributed regions, which can be heterogeneous, which have different components, which have locations, which have connections, bandwidth, which is not something that the same kind of bandwidth and latency you have in the data center. So once we extend the Kubernetes to do so, then we develop those application user interfaces that uses those deployments tools. Like you've seen, we don't have a common deployment that is from Kubernetes, but we have a Fog Atlas deployment, which is a different kind of deployment tool. That and we have developed our interfaces on top of that. Of course, if you want to have more information about these tools, just drop us an email. Basically, I will give also the details about our concept, our things later on. To the second question, I still see open. What is the innovation of the center compared with other automatic deployment tools in Azure or Amazon platform? Well, first of all, we are more targeting different kinds. So Azure and Amazon, they give you mostly the possibility to operate things over their infrastructure. We are thinking to all of those, and it's a huge amount of players that are considering their own infrastructure and where to deploy those services. But besides that, we do not only have the orchestration part, we have all the parts related to AI optimization, the packaging of your AI application. So all the things that Sengvu and his team, for instance, are doing with respect to preparing your AI. So it's a little bit of services and tools that provide you for the possibility, especially if you're not going to deal with the public cloud resources. I don't know if Sengvu wants to add anything on this, and I hope I have answered, or if anyone wants to answer to some of those questions as well, since we still have some minutes.
Well, actually, you have mentioned almost a very important aspect of our innovation. But I just add one thing. So I think some big companies like Amazon or Microsoft Azure, we are going to the same goal. We want to use the edge device to deploy our AI services, so that we can improve our end-to-end services. And one of the innovations from my side is we are trying to provide some standard way to control the AIs that are deployed on the edge devices. So I cannot go into the very detail here, but actually we are working on international standardization body to define a standard way to configure and control the deployed AI microservices. So I think that can be a good differentiation between our approach and the other major companies, I guess. Thank you.
Thanks a lot for complimenting my answer. And then I have maybe one last question. I will keep it open. Is what is the issues of deployment of those solutions? I guess it was in regard to, in general, edge solutions. In regard to decarbonization, I guess it was the question about. I don't know if anyone in the panel or in the panel on the speakers would like to answer this. So it is, of course, decarbonization, and perhaps energy concerns are becoming very much important. So, I mean, I'll leave this open if there is anyone that wants to answer to this from panelists or consortium members. Please, Mohsen.
Can I very quickly interject here? We have a project called Aniara, European Aniara. It's a Celtic Next collaboration that Konica Minolta is a part of. One of our partners, it's a relatively huge, it's 11 million contribution totally with Opel, Ericsson, Konica Minolta, and a bunch of other companies. We are actively working on this, which is energy consumption, both from the point of green initiatives and the point of view of, again, cost. So it goes both ways. It is, we have a partner, RISE, in Sweden, which has dedicated resources to answer this question. The good news is the new chassis, new computing devices are consuming a lot less than what they used to. And presumably, if you look at this as an opportunity to utilize, to install your edge places in locations that are producing less carbon, like places with solar panels or places with wind energy, you could be very effective, very, very much more effective than what we are currently is. But this is an active part of research. Two good news. Software-wise, we are progressing a lot, but hardware chassis are getting a lot better as well. And new computing devices are indeed consuming a lot less energy.
Thanks a lot. I think we have answered, thanks, Mohsen. I think we have answered live, and it's now noon, so we are at the end of our slot. I think we have answered live to those questions that were still open, and I saw Sengvu, really amazing, and Guillaume answering to a lot of questions in the chat directly written, writing those answers down. If you're still not convinced, or if you want to know more, just drop me or an email. I can dispatch it, or get in touch with the project in any way you believe it may be useful for you, so that we can discuss on the research and development perspective, or even open whatever kind of collaboration you may think about. So this basically closes this webinar today. I'm sorry we didn't. There was this nice opportunity given by HiPEAC to use a tool to have a virtual room where people could meet, but we are already at the end of the slot, so we won't use it. Before closing, I would like to thank first of all our panelist speakers, Yang-Woo Young, Danilo Ardagna, Cristobal Cordero, and Mohsen Amiri Besheli. Your participation has been really important, and you have given really insightful comments and feedback to our audience. I really believe it's going to be precious information. I would like to thank also, for sure, Sen-Woo, the other coordinator of the project, and Guglielmo for their presentation, HiPEAC for hosting us, and Clara Pezuela from ATIS for helping us setting this up with HiPEAC. So that's it on my side. Thank you all for attending, of course, our attendees, and thank all the speakers. And wish we can meet soon in physical, face-to-face. And in the meantime, we continue collaborating. Thanks a lot.
Thank you.
Thanks to you.
Thank you.
Thanks to everyone. Bye-bye.
Bye-bye.
Bye-bye.